Okay, so this is a first lecture, vector valued functions. Module 1. So before going to vector valued function, let me define what is a vector. So a vector is simply an object which has both magnitude and direction. For example, if we can for example we can say uh, velocity is a vector which has both magnitude and direction. Force is a vector, example velocity, force, etc. Okay, and the scalar quantity which has only magnitude. So let me write an example. So, suppose this point 2 1, so v equal to 2 1. So this can be represented as 2I plus j. So the magnitude is the length of this vector, and direction is the direction pointing by this vector. So this is an example for vector valued function in two space. Two space means in plane. And if we want to find out a vector valued function in vector in three space, for example, if I take a point here 1 1 1, so v is a vector 1 1 1. So you can represent it like this, I plus j plus k. So this is the definition for uh, vector valued function. So let us the vector valued functions you already studied in your +2, vectors, and addition and subtraction of vectors, multiplication of vectors, all those things you have studied in your +2. So today we will discuss vector valued functions. Okay, so I will define what is vector valued function. So a vector valued function, a vector valued function r of t in three space is represented by r or r of t is equal to x of t, y of t, z of t, which can be represented as x of ti plus y of ti, tj plus z of tk. The functions x of t, y of t, and z of t are called component functions of r of t. Okay, so this is the definition for a vector valued function in three space. If we want to define a vector valued function in two space, we can represent it by r of t is equal to some x of t, y of t. So there is only two component function. So this can be written as x of t I plus y of t j. Okay, so this is a definition for vector valued function. So here each component function x of t, y of t, and z of t are component functions called component function. An example, here we have given an example, r of t is equal to ti plus t square j plus t cube k. So here what is x of t? So instead of x of t, here our function x of t is equal to t, y of t is equal to t square, y of t is equal to t square, and then what is z of t? Z of t is t cube, right?
TQ.
Okay, so this is the definition for vector valued function. So now we will define what is limit and continuity of vector valued function, and also derivative of vector valued function. This is very simple because we will use component wise limit and continuity. So if you want to find out a limit of r of t, okay, here we will find the limit of x of t I plus y of t j plus z of t k. That means component wise limit. So that is Okay. Okay. So if r of t is equal to x of t I plus y of t j plus z of t k is a vector valued function, then limit t tends to a. What is the meaning of t tends to a? That means our function value t approaches a, the value of function approaches. So for that, if you want to take the limit t tends to a r of t, we will take component wise limit. That is limit t tends to a x of t I plus limit t tends to a y of t j plus limit t tends to a z of t k. So provided this limit exists, provided all these component functions, limit of all these component functions exist. A vector valued function r of t is said to be continuous. So we know that it is continuous. For example, if in one variable case, if all limit a function f of x is continuous at x equal to a, if we know that right hand limit f of x equal to left hand limit f of x equal to the limit at that value at that point. So similarly here the continuity of the vector valued function are to be is said to be continuous at t equal to a if limit t tends to a r of t is simply limit t tends to a r of t is equal to r of a. So instead of a t we can write a. Then if that limit is equal to r of a, then we say that r of t is continuous on an interval if it is continuous. Okay, then we say that r of t is continuous at a point t of a. So r of t, this vector valued function is continuous if it is continuous on an interval. Okay. So similarly, a derivative of vector valued function. So what will be the derivative? Okay. So please tell me what will be r dash of t. If r of t is this, then what will be r dash of t? Limit is component wise limit. We have taken component wise limit. Then what will be derivative? Derivative and the
Component wise
derivative, right? Okay. So that is d by dt of x of t I plus d by dt of y of t j plus d by dt of z of t k. So we will take component wise derivative. Then what will be integral? Similarly, what will be integral? Integral r of t dt. This must be component wise integral. Integral x of t dt I plus integral y of t dt j plus integral z of t dt k. Okay. So it's very simple. That means we are only taking the component wise limit, derivative and integral. Okay. So let me take an example. So let me clear this. So this is so now we will do few examples. So example, let let r of t is equal to t square I plus e raised to tj minus 2 cos pi t k. Then what is limit t tends to 0? T tends to 0. R of t is we will take component wise limit. So what are the components here? T square, x of t is t square, y of t is e raised to t, and z of t is this. So we will take component wise. Limit t tends to 0 t square I plus limit t tends to 0 e raised to tj plus limit t tends to 0 2 cos pi t k. That is equal to, this limit becomes 0, right? Plus this will become e raised to 0, that is 1. And this will become cos 0. Cos 0 is 2, right? Minus 2. So that is j minus 2k. So this will be the answer. Now we will do another example. So tell me what will be the answer here. Solution. R of t. What will be the limit? Okay, I think this is same as that, right? The same question. Limit t tends to 0. Okay. Same question. 0I plus j minus 2k. Now tell me what will be the derivative here. R of, if R of t is equal to t square I plus e raised to tj minus 2 cos pi tk, then what will be r dash of t? Anybody?
2t 2t cap plus e raised to tj plus
Plus e raised to
2 pi cos
tj
sin pi t
minus
2 pi sin pi
minus
t.
plus 2 pi sin pi t. So that is, so we will take the component wise addition. Okay, right. Okay, now so next is vector form of a line segment. So you know what is the equation of a line segment joining 2 points, right? If x1 x2 y1 y2, you know that what is the equation of line segment joining these 2 points, right? X1 x minus x1 divided by x2 minus x1 uh, equal to y minus y1 divided by y2 minus y1. Sorry, x1 y1 x2 y2. So this is the line segment joining 2 points. Now so now we want to find out the vector equation for the line segment joining 2 points in space. There are two space and 3 space. So let me define. Let r naught is a vector in 2 space or 3 space. Okay, with the initial point at the origin, then so what is the initial point? Is at origin means 0, and is parallel to a vector v, then can be expressed as, can be, the line passes through the uh, terminal point of r naught and is parallel to v, can be expressed as the form r equal to r naught plus tv. So what is the equation for line passing through the point r naught and is parallel to a vector v? This can be expressed as r equal to r naught plus tv. So that is the equation of line passing through the point r naught and parallel to a vector v. So that means if this is a v, then a point r naught is this, then the line passing through the vector and passing through the point and parallel to v is of the is it can be expressed as r equal to r naught plus t. Now we want to represent a line segment joining 2 points r naught and r1. So suppose if r naught and r1 are vectors in 2 space or 3 space with their initial points at origin, then the line that passes through the terminal points of these vectors can be expressed as the form r equal to 1 minus t r naught plus t. t r1. That means if you have 2 points, suppose this is r1, r0 and r1, these 2 points, then the line segment joining this equation of the line segment joining this point is simply r equal to 1 minus t r0 plus t r1, where 0 less than or equal to t less than or equal to 1. For example, if you want to find out the line segment joining 2 points, suppose 1, 2 and 1, 2 and take 3, 1. So if you want to find out the equation of 2 points joining,
audio break ആണ്.
audio break ആണ്. There will be some few network issue. Okay, so
Hello.
okay.
Hello.
One minute. Okay, so ഇപ്പൊ കേൾക്കാൻ പറ്റുന്നുണ്ടോ? Hello.
Yes, sir. ഇപ്പൊ കേൾക്കാം.
Okay. So
Sir.
Yes, sir.
okay. So if we want to represent or find a vector equation of line segment joining 2 points, suppose we want to find r0 is equal to 1, 2 and r1 is equal to some 2, 3, then the line segment joining 1, 2 and 2, 3 is r is equal to r0 instead of 1 minus t 1, 2 plus t times 2, 3. So if we and 0 less than or equal to t less than or equal to 1. So this is actually equal to 1 minus t 2 minus 2t plus 2t 3t. So this is simply equal to 1 plus t and 2 plus 2 plus t. So this is the vector equation. So you can write this as a vector equation of the form 1 plus ti plus 2 plus t j, 0 less than or equal to t less than or equal to 1. So any 2 points, any line segment joining 2 points can be find by using this vector equation. This is very important. Okay, so now I will define what is tangent lines. So tangent line is simply equation of the tangent line. So if r0 is this point, this is the vector r of t0, that is r0, and we know that this is the tangent at that point, r dash of t0. So we want to find out the line to the graph, tangent line to the graph, equation of the tangent line to the graph at t0. So simply that is the line which is parallel to the tangent vector. So this is the tangent vector r dash of t. So the vector equation is of a line tangent line to the graph r of t is r equal to r naught plus t v naught, where v naught is equal to r dash of t naught. So this is the vector equation for a line tangent line to at a point. So that is very important. So now we will do a problem. So the first problem is find parametric equation of a tangent line to the circular helix x equal to cos t, y equal to sin t, z equal to t, where t equal to t naught. And first we want to find out the parametric equation for the tangent line. Then find the parametric equation for the tangent line at the point t equal to pi. So here we have given x of t, y of t, and z of t. So first we will write it in the form of a vector equation. So vector equation of the helix is r of t equal to cos ti. So x of t is cos t plus sin tj plus tk. Now we know that what is tangent line equation for the tangent line, r naught r of t naught plus uh, t times or v times v naught, t times v naught, or v naught is r dash of t naught. So first we will find out r naught. R naught is r of t naught. Instead of t we will put t naught. Okay, then we will find v naught. V naught is uh, so the equation is r equal to r naught plus t v naught. So v naught is this r dash of t naught. So derivative of cos t naught is minus sin t naught I plus cos t naught j plus k. Now we know that the vector equation of the tangent line at t equal to t naught is r equal to r naught plus t v naught. So just we will apply that formula, then we will get the answer. So just substitute this. Okay, so we get r is of the form in a vector equation. So now we will write in a parametric form. Parametric form means let take x of t, x equal to this, and y of t is this, and z of t is this. So we will write in parametric form. So in parametric form means we are taking x, y, z coordinates. So at t naught is equal to pi, you just substitute pi instead of t naught. Okay. So similarly, you can do this problem. So write down this problem. This is your homework. Find the parametric equation of the tangent to the curve r of t equal to t square I plus t cube j plus 3tk at t equal to 1. Have you completed? So the solution is here. I will show you the solution. This is the solution. Okay. So write down this problem. So So we know that how to find out the tangent. Now I will give you few problems in your WhatsApp group, and these are the exercise problems. I will send in your WhatsApp group photo of this in your WhatsApp group, and you just uh, work out this problem. Okay. Okay. Any doubt? Any doubt? You have? Anybody have any doubt? Is it clear?